Hi, I'm Kevin from Singapore, and today I'll be talking about the basic ideas of audio. The two main ideas that will be discussed are amplitude and frequency. So without further ado, let's get into it. Okay, so what is amplitude? The scientific definition of amplitude is the maximum displacement of an oscillating particle from its equilibrium position, and in the context of sound and air, the oscillating particle refers to an air molecule. Amplitude determines the loudness of sound we perceive. So, the higher the amplitude of the sound wave, the louder we perceive the volume to be. Likewise, the lower the amplitude of the sound wave, the softer we perceive the volume to be. Let me illustrate this using my guitar. As you can probably hear, the first strum actually produces sound wave with higher amplitude, while the second strum produces sound waves of lower amplitude. Now up next we have frequency. The scientific definition of frequency is the number of complete wave cycles per unit time, and it determines our perception of the pitch of the sound produced. The formula for calculating frequency is given by frequency equals to 1 over t, where t is the period of the wave, or how long it takes for the wave to travel a distance of one wavelength. Now here's an example of how sound with high frequency would sound like. And here's an example of how sound with low frequency would sound like. Now all the ideas we have discussed so far can actually be represented on the oscilloscope diagram when we do our recordings using our DAWs. We discussed quite a few concepts and terms today, so let's look at a simple example to help you consolidate all that we've learned. This is a simple oscilloscope diagram. As you can see from the diagram, the vertical distance from the time axis to the peak of the wave represents the amplitude. And looking at the values given on the axis, the amplitude of the sound wave is 1 decibel relative to full scale. Now as for the time period, it can be seen from the diagram that it is 4 seconds. Earlier we learned that frequency is equivalent to 1 over the period. Hence, with the period given, we can determine the frequency of the sound wave, which is in this case actually 0.25 Hz. As illustrated from the example, sound waves actually provide us with quite a lot of information. While the concept of amplitude is relatively easy to grasp, the calculation of frequency may seem like just a bunch of numbers to us. So, to apply this to the context of pitch, here's a table which directly relates the frequency of the sound waves to the pitch of musical notes. For example, this is a sound wave produced by a 440 Hz tuning fork. Referring to the table, we can see that this is actually an A note. Yep, and with that I've come to the end of the presentation. I hope you guys enjoyed it and thanks for watching.